Hello, in the second video for chapter 4, we're going to be looking at quotient rule, how we take the derivative of two functions that are being divided. We're going to call the numerator f of x, and we're going to call the denominator g of x. So to find the derivative, you take the derivative of the numerator times the original denominator, subtraction the original numerator times the derivative of the denominator, all over the original denominator squared. Okay, so in this first example, if we had the numerator of x cubed over the denominator of x squared plus 1, we take the derivative of the numerator, so the derivative of x cubed would be 3x squared times the original denominator, subtraction the original numerator times the derivative of the denominator. So the derivative of x squared is 2x, and the derivative of 1 is 0, all over the original denominator squared. And then we can simplify the top. So here, to simplify the numerator, we can take the 3x squared times x squared, that would be 3x to the fourth. 3x squared times 1 would be plus 3x squared. And then here, we have the subtraction, x cubed times 2x would be negative 2. X cubed times x to the 1 would be x to the fourth. Then we can combine like terms. 3x to the fourth minus 2x to the fourth is 1x to the fourth plus 3x squared all over x squared plus 1 squared. Okay, so we'll do this other example here. If we're going to take the derivative of 2x to the third minus 4x plus 5 all over 4x cubed, well, we follow the formula. The derivative of the numerator, the derivative of 2x cubed is 6x squared. The derivative of minus 4x is minus 4. Derivative of 5 is 0. Times the original denominator, 4x cubed, subtraction, times the original numerator, times the derivative of the denominator. Derivative of 4x cubed would be 12x squared, all over the denominator, 4x cubed squared. And then again, you can simplify the numerator and simplify the denominator. But we're just going to practice the rule right now. Okay, so let's look at a third example. What if we had, we're trying to find the derivative of 1 minus 3.2 x raised to the negative 0.2 all over x plus 1. We go slowly through the steps. The derivative of the numerator, derivative of 1 is 0. The derivative of minus 3.2 x to the negative 0.1 would be negative 0.1 times negative 3.2 is positive 0.32. Subtract 1, we get x negative 1.1. Times the original denominator, subtraction, original numerator, times the derivative of the denominator. Derivative of 1x is 1, derivative of 1 is 0. All over the original denominator squared. Then you would simplify the numerator, and you can simplify the denominator as well. Now, what if we had the numerator with two things being multiplied and then divided by x minus 1? So you're probably thinking we could do product rule and then do quotient rule, but I would recommend stopping for a moment and thinking about it, saying, before I take the derivative, can I simplify it first? Well, if you notice, in the numerator, we have x plus 1 times x plus 2. If we distribute x times x squared, x times plus 2 is plus 2x, 1 times x is plus 1x, 1 times 2 is 2. The numerator simplifies to x squared plus 3x plus 2 over x minus 1. Now we don't have to worry about doing product rule and quotient rule, or actually quotient rule, product rule inside of it. Then we have a simpler form. Now we're just going to do quotient rule. So let's do the full simplification. So look at the numerator. Take the derivative of the numerator. Derivative of x squared is 2x. Derivative of 3x is 3. Derivative of 2 is 0. Times the original denominator. Subtraction, the original numerator, x squared plus 3x plus 2, times the derivative of the denominator. Derivative of x is 1. Derivative of minus 1 is 0. Then we can simplify the numerator. So we're going to do 2x times x, which is x squared, 2x squared. 2x times negative 1 is negative 2x. 3 times x is 3x. 3 times negative 1 is negative 3. We're going to distribute the negative and the 1 at the same time. So negative 1x squared, negative 3x, and negative 2. Combine like terms. 2x squared minus 1x squared is 1x squared. Negative 2x plus 3x is 1x. 1x minus 3x is negative 2x. Negative 3 minus 2 is negative 5. And then if you simplify the numerator, x minus 1 times x minus 1 gives you x squared minus 1x plus 1, which simplifies to x squared minus 2x plus 1. So again, there's simplifying, a lot of simplifying in the bottom, but we're learning the quotient rule. Now, the next section is going to be talking about the calculation thought experiment, and basically, how do you know what you're going to do? Quotient rule, product rule, and we're going to learn some more later. But basically, if you plugged in numbers for x, and whatever the last step would be, that's what you do. So in this case, I have one function being multiplied by another function, so it's product rule. But if you ever got a little lost at that, if you plugged in 0 for x, plug in 0 for x, and you work this out, the last thing you do is multiply. That's product rule. Same thing here. We have two functions being divided. That'd be quotient rule. But if I plugged in a 1 here and a 1 for the x, the last thing you would do is divide. That's quotient. Or in this one, we have x squared plus 4x minus 1 times x plus 2. Well, I would take the derivative of x squared, the first part, and then I would do product rule to the second part. So we can mix. And then what if I had 3x squared minus 1 all raised to the fifth? We haven't learned that yet. That will be the power rule, the chain rule. So the last example we're going to do is, what if I had find the derivative of 6x squared plus 5 times x over x minus 1? Well, to simplify a bit, 5 times x would be 5x in the numerator. Now I just have to deal with 5x over x minus 1. Then I would treat them, because of the plus, I would take the derivative of 6x squared, which is 12x. But to take the derivative of 5x over x minus 1, I need quotient rule. So I taught you product rule, I'm teaching you quotient rule, and you use them when you need it. So to take the derivative of 6x squared, that's 12x. I didn't need product or quotient rule. But to take the derivative of 5x over x minus 1, we need quotient rule. So derivative of the numerator is 5 times the original denominator, x minus 1, subtraction, original numerator 5x, times the derivative of 1x is 1, derivative of 1 is 0, all over the denominator x minus 1 squared. Now the 12x we continue to bring down, but we can distribute the 5. 5 times x is 5x, 5 times 1 is 5, so 5x minus 5. Negative times 5x times 1 is minus 5x. Keep on bringing down the 12x. 5x minus 5x is 0, so we're left with negative 5 over x minus 1 squared would be your final answer of 12x minus 5 over x minus 1 squared. Okay. Then the next video we'll learn about chain rule.